Welcome to the sum and difference rules. This is part 4 in a derivative rules series that is going to help you learn how to knock out derivatives. Don't forget to subscribe and like. Let's jump right into the sum and difference rules. So the sum and difference rules for derivatives are actually really simple. The sum or difference of two differentiable functions, f of x and g of x, is itself differentiable. Moreover, the derivative of f of x plus g of x, or f of x minus g of x, is the sum or difference of the derivatives. So here's the rule. To find the derivative with respect to x of a function f of x plus another function g of x, all you have to do is find the derivative of f and add the derivative of g to it. Come on, it's so easy. And even if it's subtraction, to find the derivative with respect to x of a function minus another function, just take the derivative of the first function minus the derivative of the second function. It's unbelievably simple to use the sum and difference rules. There's no tricks here at all. So let's just dive into a series of examples. So here we have a classic polynomial made up of three terms, 4x cubed, negative 4x, and 5. So basically we have three mini functions all coming together with subtraction and addition to create one large polynomial function. So to find the derivative of this function, we simply have to find the derivative of each term. That's it. That's how easy this is. So let's find the derivative of this function. All right, the first term is 4x cubed. I'm going to need that power function. 4 is a constant multiplier that just multiplies out in front, just kind of stays there. 3 falls down from the power rule as my new coefficient. X to the second power. 3 minus 1 is 2. All right, we'll clean that up in 1 second. All right, now what about this next part right here, the negative 4x? All right, well, negative 4 is a constant multiplier. The 1, remember that's x to the first, is going to fall down in front. My new power is going to be 1 minus 1, which is going to be a 0. And then finally, for this last part right here, well, that's just a constant. What's the derivative of a constant? Well, the derivative of a constant, you should know, is 0. So I took the derivative of each part of these three different terms combined together, and now I just got to clean it all up. So here we go. 4 times 3 is 12, x squared, minus 4. Now remember, negative 4 times 1 is negative 4. X raised to the 0, 1 minus 1 is 0. Well, anything raised to 0 is 1, so that just becomes a 1. Negative 4 times 1 is just negative 4. And then obviously, the derivative of that constant in the back is just 0, so I don't even have to write anything there. There's no point writing 0, so I'm done. The derivative with respect to x of 4x cubed minus 4x plus 5 is 12x squared minus 4. Now listen, I know some of you are really smart. I did all of that really slowly, taking my time showing my work. Most kids are going to learn how to use these rules very quickly. They're just going to say 3 drops down in front, 3 times 4 is 12, new power is 3 minus 1, which is 2, minus negative 4x, that's linear. Linear is just the slope, right? So negative 4, that's it, done. And the derivative of 5 is 0, not even worth writing it down, so therefore the derivative is 12x squared minus 4. Really simple. All right, here's another one that's much longer, but essentially I have a long polynomial here with 1, 2, 3, 4 terms. All I got to do is find the derivative of each term and put them all together, and I got my derivative. So negative 3, 5 falls down in front, new power is 4. Negative 4, 2 falls down in front, new power is 1. Positive 5, 1 falls down in front, new power is 0. The derivative of a constant is 0. That was the very first rule we talked about back in part 1 of this video series. So cleaning this up, I have a negative 15x to the fourth minus 8x to the first plus 5. Because remember, x to the 0 is 1. 5 times 1 times 1 is just 5. So the derivative with respect to x of my function, now notice what I did there. I didn't want to write all of this out, so I just wrote f of x, right? They're the same thing. There's literally an equal sign right there. So the derivative of my original function with respect to x is negative 15x to the fourth minus 8x plus 5. Now you might be wondering, you do that on every problem, Mr. Princhek. You always use this new notation. Yeah, I do, because I really like it. Do you have to do that? Honestly, no. You have to find the derivative. Whether you call it f prime of x or you use this new notation d of x, it's the same thing. As long as you have the derivative, that's all that really matters at the end of the day. All right, here's another one. Another weird kind of function that has 3 parts. 1, 2, 3. Now, before I could jump and utilize any of my rules, the first thing I'm going to do is I'm going to turn that very first part right here into a power function. Because as is, it's not a power function. But if I simply bring that x to the numerator where it can become a negative 2, now I have myself a power function. That was just an algebra skill, so I can now use the power rule 3 separate times. All right, here we go. Negative 2 falls down in front. Now listen, I can start doing some of this math in my head. When that negative 2 falls down in front, 2 times negative 2 makes negative 4, x to the negative 3. Negative 2 minus 1 is negative 3. Plus, the 4 falls down in front and smashes into that 5, and they multiply to make a 20, x to the new power of 3, minus 7. Now, technically, my new power on that x is 1 minus 1, which is 0. But come on, you've been watching long enough to know that x raised to 0 is just 1. So I have negative 4x to the negative 3 plus 20x cubed minus 7. I don't need to write x to 0 because x to 0 is just 1. Now, the only thing I'm going to do is remind you that having negative exponents is kind of bad grammar in English class. So we're going to take that negative 3 as a power and move it to the denominator where it can become x to the positive 3 plus the 20x cubed. He's totally happy. Minus the 7. Beautiful final answer there. All right, here's another one that needs a ton of cleanup work. But at the end of the day, I have one function minus another function plus another function. So I'm going to clean this up a little bit. That way I can use the power rules. X raised to the 1/2 instead of a square root. Minus 2/5 x to the negative 3. The 2 and the 5 stay put, right? There's nothing wrong with the 2 and the 5. It's the x in the denominator that I want to move up so I could use the power function there. But 2/5 is just a constant multiplier out in front, plus a constant of just 8. Now I'm going to go ahead and find the derivative g prime of x. 1/2 falls down in front. New power is negative 1/2. 1/2 minus 1, negative 1/2. Minus 2/5. The negative 3 falls down in front. I'm going to put in parentheses there because I got to multiply. I don't want you to think about subtraction there. It's going to be negative 2/5 times that negative 3. X to the negative 4 plus, well, the derivative of a constant 8 is 0. That's the constant rule. All right, now let me just clean this up a little bit. We don't like negative exponents, so that x to the 1/2 is going to move to the bottom, where it could actually become an x to the positive 1/2, which is a square root of x. Minus, all right, now let's see here. I'm going to get a positive 6/5. Negative 2/5 times that negative 3 made a positive 6/5. But the x is going to move to the denominator. That way it does not have that negative exponent. And I obviously don't have to write 0. So there's my final derivative right there, all looking pretty. All right, now here's the problem that's going to throw a lot of kids off. They're going to be like, oh, wait a minute. That's not a power function. A power function is a base of x raised to a real number. This time my base is more than just an x. It's a 2x minus 3. So we really can't use the power function right here. But if we simply square this out, we can. 2x minus 3 squared is 4x squared minus 12x plus 9. All I did was square that out. I took 2x minus 3 times 2x minus 3. Come on, it's not that hard. 4x squared, positive 9, negative 6x. Another negative 6x makes negative 12x in the middle. Now I could go ahead and use the sum and difference rules in combination with the constant multiplier rule, the power rule, and even the constant rule. I'm literally using every single rule we've learned so far in this problem. All right, so the derivative of this function is going to be 8x minus 12. Now notice how I didn't show any work there. I went through that problem really fast, and I hope that you can eventually get to that stage as well. But let me just walk through it. The 2 came down in front. 4 times 2 smashed together and made an 8. New power is x to the first. The 1 came down in front, smashed into the negative 12, and negative 12 times 1 is still negative 12. My new power is x to the 0, but you don't have to write x to the 0 because x to the 0 is just 1. And then the derivative of a constant, 9, is 0, so don't even write it down. Boom, there's my derivative. All right, here's another one. Again, the way this looks, you're like, wait a minute, I can't use any of the rules we've learned so far. We haven't learned any multiplication rules. We've only learned the sum and difference rules so far. But if I simply multiply this out, just using basic algebra, I get an x cubed minus 4x squared plus 2x squared minus 8x. All I did was use my rules. Algebra, multiply. Now I'm going to combine some like terms. I get a negative 2x squared when I like combine those like terms, minus 8x. Now that I've turned this into the sum or difference of 3 separate functions, I could use the constant multiplier rule, and I could use the power rules to make finding the derivative of this function really, really simple. 3 falls down in front, new power is a 2, minus 2 falls down in front, multiplies by the 2 that's there to get a negative 4, x to the first. You can write the first, so you don't have to. Minus 8. Now again, it's technically 8x to the 0, but don't write x to the 0. We all know x to the 0 is a 1. And again, there was a 1 here. It falls down in front. Negative 8 times 1 is negative 8. X to the 0. No point in writing x to 0 because it's just 1. So there is my final derivative. Really, really simple. So, listen. The sum and difference rules are really, really simple. If you got two functions being added together, find the derivative of each, add the derivatives together. Or if you're subtracting, subtract the derivatives. It's that simple of a rule. So notice how in this video we start to incorporate all the other rules that we've already learned. They all do kind of come together. And you start to realize in a lot of problems, you're using multiple rules together. All right, hopefully you are learning how to knock out derivatives really easy. Don't forget to like and subscribe, and I really hope you're learning.